Hello friends, how are you? I am Professor Rajendra Koranne from Teach Easy. In this video lecture, we will see how to find out the moment of inertia of angle section. So let us see the problem. Calculate moment of inertia of angle section 100 mm by 80 mm by 10 mm about its centroidal axis. Now, let us first draw the figure. What is angle section? Angle section is L section because it looks like L. So this is 100, this is known as longer leg, this is 80, this is shorter leg. So always keep in mind, generally longer leg is kept vertical, so this is 100 mm, this is 80 mm and the thickness throughout is 10 mm. Okay? So this is known as angle section, 100 mm by 80 mm by 10 mm. We want to find out moment of inertia. Now here in this section, you will see that this particular angle section is an unsymmetrical section. It is neither symmetrical about horizontal axis nor it is symmetrical about vertical axis. Therefore, our first job is to find out the position of the centroid, that is x bar and y bar. From some of the comments which I received on the previous videos, I came to know that some students want to find out step-by-step procedure to calculate x bar and y bar. So the same I will tell you here. So let us first find out the position of the centroid. Now for that purpose, I will divide this into two rectangles. This is first figure is rectangle 100 mm by 10 mm. Second figure is rectangle. How much is this one? 80 minus 10. So it is 70 by 10. So, okay. So, first figure is 100 mm by 10 mm. Therefore, its area is 100 by 10. What will be area? So, A1 is equal to 1000 mm square. Do you understand it? This is 100 mm by 10 mm, so it is 1000 mm square. Now let us see what is the value of x1. Now what is x1? x1 is the distance of centroid of the first part from y-axis or this particular one. Okay, so this is the centroid. So what will be x1? x1 is distance of centroid from the vertical. You can see this is origin, so this is y-axis and this is x-axis. So this particular thickness is 10, so what will be this distance? This will be 10 by 2. So x1 is equal to how much? 10 by 2. That is 5 mm. Let us see what is y1. Now what is y1? y1 is the distance of centroid of the first part from x-axis. Y is always vertical distance. So as this is 100, what will be this one? Come on, y1 is equal to, can you tell me, 100 divided by 2, that is 50 mm. Do you understand this? What is A1? A1 is area of first part, x1 is distance of centroid of the first part from y-axis, y1 is distance of centroid of the first part from x-axis. Similarly, we will go for the second part. What is the second rectangle? See, look here. This total distance is 80, but first part we have taken up to this. So 10 will be deducted from 80. So what is this distance? 70 by 10. So second part I will say 70 mm by 10 mm. Hence its area will be, come on, what will be its area? It will be A2 will be 70 into 10, that is 700 mm square. Now let us find out the centroid of second part. Second part is this rectangle, so this will be centroid of second part. Okay, so what will be distance x2? X2 will be the distance of centroid of the second part from y-axis. Therefore, this is centroid. We want this particular distance from here to here. Now this is 70, so this will be 70 by 2, that is 35, plus we want it from this, so you will have to add 10 to it. So it will be 10 plus 70 divided by 2. So it will come out to be 45 mm. What will be y2? What will be y2? Y2 will be distance of centroid of second part from x-axis. So this is that distance. This is 10. So definitely y2 will be equal to 10 upon 2, that is 5 mm. Now we will calculate x bar and y bar. What is the formula for x bar? X bar is equal to A1 x1 plus A2 x2 divided by A1 plus A2. You will substitute the values of A1 as 1000, x1 as 5, A2 as 700, x2 as 45, and 1000 plus 700, that will be A1 plus A2. If you substitute all this value, you will find out this value of x bar as 21.5 mm. From O. So this is that distance. This is x bar 21.5 mm from O. Similarly, calculate y bar. So what is the formula for y bar? Y bar is equal to A1 y1 plus A2 y2 upon A1 plus A2. Put the values once again. A1 is equal to 1000, y1 is equal to 50, A2 is equal to 700, y2 is equal to 5. Substitute all these values. You will get this value, calculate it. You will get this value as 31.5 mm, definitely from O. So this distance, that is 31.5, remaining distance 100 minus 31.5 is calculated. Here this is 21.5, remaining distance will be 80 minus 21.5. So it is calculated in this manner. This is the centroid of the section. The horizontal axis passing through the centroid is xx and the vertical axis passing through the centroid is yy. So this is how we have to calculate the position of the centroid. So have you followed how to find out position of the centroid? Okay. Now let us proceed further to calculate Ixx and Iyy. Now this figure is not at all symmetrical about any axis. Both the rectangles are unsymmetrical about xx as well as yy axis. So we will have to use parallel axis theorem. Okay. So let us go for Ixx. So Ixx will be Ixx 1 plus Ixx 2. So this I will not separately calculate Ixx1 and Iyy1. Directly I will write all the values. Now what is Ixx1? That is movement of inertia of first part about xx axis. So this is xx axis of first part and we will have to shift from here to here by parallel axis theorem. So for Ixx1 it will be I self about xx axis plus area into h square. So what will be h square, that we will see now. Okay. So Ixx1. So tell me BD cube by 12. What is B? 10. What is D? 100. Cube of that divided by 12. This is self-centroidal axis plus area into h square. What is area of first part? We have already calculated 1000. Now this is important. What will be h? See, look here now. H will be the distance between the two parallel axes. So from here we have to shift it to here. So this will be the value of H1. So tell me what will be this value H1? This value H1. See, look here. This is 100. So how much is this distance? 50 minus 31.5. Or you can do it 68.5 minus how much is this distance? 50. So 68.5 minus 50. How we have calculated 50? 100 by 2. Do not forget to make it square. So this is moment of inertia of the first part, that is first rectangle. Okay. Now moment of inertia of the second rectangle about x-axis. So this is second part. First one, itself moment of inertia BD cube by 12. What is B? B is 70. What is D? 10. So it will be 70 into 10 cube divided by 12 plus area is 70 into 10, that is 700 into h. Now look here, what will be h in this case? H is distance between this axis and this axis, because b d cube by 12 is mi about this axis. So from here we have to shift it. Therefore this will be the value of H2. So can you tell me what will be the value of H2? See, look here. What is this distance here to here? It is 31.5. And what is this distance? This thickness is 10. Half of that is 10 by 2. So it will be, come on, tell me, 31.5 minus 10 by 2. Don't forget to make it square, and this comes out like this. This is Ixx2, Ixx1 plus Ixx2. If you calculate this value, calculate it separately for this and this and add them, you will get the answer of Ixx as 1.67 into 10 raised to 6 mm raised to 4. You must get a habit of correct calculation. For that, lot of practice is required. So this is the first answer, that is moment of inertia of angle section about horizontal centroidal axis XX. Do you follow this? Now, let us calculate IYY. For IYY also, both the rectangles are not symmetrical. Okay? So, what I will write? Come on, tell me. Again, what will be IYY? IYY is equal to, come on, IYY 1 plus IYY 2. So let us write the steps again. So for IYY, so IYY of first. What is IYY of rectangle? DB cube by 12. So just interchange the places. So what is D? Is 100. What is B? Is 10. Its cube divided by 12. What is this? Moment of inertia of first part about its centroidal axis, this one. From here you have to shift it for this one. So what will be the value of H in this case? So this is again, I will say H1, or you can say H3. So what is the value of H3? What is this? 21.5. What is this? 5, 10 by 2. So it will be area. What is area? Plus, come on, what is area of first part? 1000 into H square. What is H? Can you tell me what is H? 21.5 minus this 10 by 2. 21.5 minus 10 by 2 bracket square. This is very important. Many a times while calculating H, we forget to make it square, plus IYY2, that is IYY for second part. DB cube. What is D of second part? 10. What is B? 70. Just interchange the places. So 10 into 70 cube divided by 12 plus area is 700 into what is H? Now look here. This is YY axis of second part and we have to shift it to this y axis. Therefore, this will be the value of H4, I will say. So what will be this value? Come on, tell me. Can you tell me what is this value? H4. May I say that it is 58.5 minus this distance. What is this distance? This is 70, so this is 70 by 2. Okay? So it will be 58.5 minus 35. How 35 is calculated? This is 58.5, this is 70, so this is 35. That is, it is 70 by 2 bracket square and big bracket complete. Okay? So calculate. You should start and you should end with the answer. That much practice you should have, and the answer comes out to be 0.95 into 10 raised to 6 mm raised to 4. So this is the second answer, that is moment of inertia of angle section about vertical axis, centroidal axis. So in this manner we have calculated Ixx and Iyy for this angle section. Do you understand this? In this problem I have explained in details the procedure to calculate x bar and y bar also. Okay. Let's now take the second problem on angle section. Calculate Ixx and Iyy of angle section 100 mm by 100 mm by 10 mm. Now, in the previous problem, it was 100 mm by 80 mm by 10 mm. Means the two legs were of different sizes. In this case, it is 100 by 100 by 10. So this is also 100, this is also 100. So this particular section is known as equal angle section. The angle section in the previous problem was unequal angle section. This is simple problem, so I will just give you the hint how to solve it. I will give you the answer and it is you to calculate this at home. Okay. Now this is 100 by 10. This is another 100 by 10 leg. Now if you fold it, you will find that this figure will be folded about this axis. So this is the axis of symmetry which is at 45 degrees, and as this is the axis of symmetry, the centroid will definitely lie on this axis. So if I say that if this is the centroid G for 45 degree, you know that sine and cos are same. So this will be x bar and this will be y bar. And as it is 45 degrees, you can very easily see that x bar and y bar are equal. So this is the advantage of symmetry. Now as x bar and y bar are equal, for this particular angle section, Ixx and Iyy will also be equal. Okay. So I will just tell you orally how to calculate it. You have to solve it at home. I will give you the answer. So for x bar, what is A1? 100 into 10. What is x1? 10 by 2, because this is origin. What is y1? 100 by 2, that is 50. Okay. This second part, now what is this distance? 100 minus 10 means it is 90. So what is the area? 90 into 10, that is 900. What is x2? As this is 90, distance of centroid will be 45 plus 10 from here. So x2 will be 10 plus 90 by 2, that is 55. y2 will be 10 by 2, that is 5. Now as usual, using the formula x bar is equal to a1 x1 plus a2 x2 upon a1 plus a2, you will get the value of x bar. Similarly, using the formula y bar is equal to a1 y1 plus a2 y2 upon a1 plus a2, you will get the value of y bar also. And the answers in this case are, so I am giving you the answer, you have to calculate at home. Just now I have explained that it is symmetrical about the axis at 45 degrees, value of x bar and y bar are equal. And it comes out to be 28.68 mm. So this is 28.68. And this is also 28.60. This is only due to, this beauty is only due to this axis of symmetry. I will write it so that one point you will have to keep in mind that when it is equal angle section, you must keep in mind that x bar and y bar are equal. Similarly, ixx and iyy will also be equal. So this is simpler than the previous problem. Hence, I want you to solve it at home. So this is regarding x bar and y bar. Let us see how to calculate ixx. Now see carefully, I am only giving you the tips. You write it at home and calculate it. Ixx will be ixx1 plus ixx2. In the first part, this was x axis of the first part. This is x axis of the complete section. So this was h1. So what was h1? What is this distance? 50 minus, how it is 50? 100 by 2 minus 28.68. Now this is the centroid of second part. Okay, you have to shift it to, come on, this one. So what is h2? This will be your x axis, isn't it? So from here to here you have to shift. So this will be the value of h2. So how will you calculate h2? Come on. h2 will be y bar, that is 28.68, minus this distance is 10 by 2, that is 5, and square of that. So from this you will get, calculate it, you will get the value of ixx, and due to the symmetry you will not have to calculate y bar separately, but it will also be same, and the answer which you will get will be ixx is equal to iyy is equal to 1.8 into 10 raised to 6 mm raised to 4. So please try to calculate at this home. I have given you the answers. Please check it so that you will get the confidence about parallel axis theorem. And definitely this problem is simpler than the previous one because it was unsymmetrical section in which Ixx and Iyy were separate. Here they will be same. Do you follow this? So this is how we can find out the moment of inertia of angle sections. Thank you.